So far we've been calculating areas, but what if I gave you a problem where you calculated the area in square inches and then I asked you to change it to square feet? Or you calculated in square meters and then I wanted square centimeters. So how do you switch? And right now we're just looking at within the system. So there are two main systems for measurement, especially of length and area, and there's the metric and the British. In the metric, the easiest thing for me to remember is that, say, 1 millimeter is a tenth of a centimeter. It's actually easier for me to remember from the bigger units. So I'd say 1 kilometer, how many meters is that? 1 kilometer is 1,000 meters. And that makes sense. Kilo is 1,000. Centi is like 100 or hundredths. So a centi, 1 centimeter is a hundredths of a meter. So 1 centimeter is 0.01 meters. See, that's the hundredths place. Or you could say 1 meter is 100 of those centimeters. Millimeter, that's 1,000th. There it is in the thousandths place. So 1 meter is 1,000 millimeters. Okay? And that's milli comes from 1,000. So we go from our base, which is the meter. With inches, feet, and yards, you know that really it's easier to go from the bigger. 1 yard is 3 feet. And you tend to know 1 foot is 12 inches. But you also know 1 yard is 36 inches. So if I were you, I would actually memorize these conversions. There's no guarantee that we're going to give it to you, especially between inches, feet, and yards. We won't give that to you. We might say something for like if switching between systems. So if I want to say how many inches is a centimeter or how many centimeters is an inch, then I might give you that measure. But within systems, you should have these memorized. So one strategy to convert is you're going to set up a proportion. If you remember when we studied a scale factor and we actually looked at the area of one object compared to another for dilation, we found out that it was proportional to the scale factor squared. Well, this is a lot like that. We're not actually shrinking it. We're just changing the units that we use to measure it. So we're going to say the new area, we're going to take the new units, and we're going to square it. And if you remember, again, that study, how we saw how it changed, it was squared, is over the, and then we do the proportion, the bottom part is the old area, and the old units squared. Then you cross-multiply and solve for the unknown. So in this example, let's first calculate the area of the triangle. We're going to do it in square centimeters. So first of all, I need to find this base here, right? And that base, I don't know. I know the height. I need that for the area of a triangle. Do I need the 25? Not for the area, but I actually do need it to find the base. See, this is a right triangle, so I can use Pythagorean Theorem to solve for it. Also, I'm going to do something a little different here. Instead of actually squaring everything out, I'm going to not use the calculator till the very end. So this is a cool thing that can save you time. So I'm going to subtract 7 squared from both sides. So I didn't even square it. Then I say, well, b squared is whatever I get when I go 25 squared minus 7 squared. But I don't really want b squared. I want b. So I'm going to take the square root of that whole answer. If you put that whole thing in your calculator, you'll get the right answer, which is 24 centimeters. So now I'm going to take that 24 centimeters and put it in for the base, and I'm going to take the 7 centimeters and put it in for the height. So 1/2 of 24 times 7 is basically 84 centimeters squared. Now I'm going to take this value here, and I want to convert it to square meters. So this problem we're doing square meters now, and I've got my 84 centimeters squared. Now I could go back and change that to 0.07 meters, and that to 0.25 meters, but that's actually a little bit of work, right? So I'm going to set up my proportion. I'm going to show you where the numbers come from. A prime, that's my new area, over my old area. Well, my new units, remember it's easier to start with one of the bigger units. It's going to be one of those units squared over how many centimeters are in a meter. There are 100 centimeters in a meter, so it's 100 squared. Remember, we're squaring both. Then I can multiply both sides. Now, I could cross multiply, but honestly, sometimes it's easier to just multiply both sides by the 84 because I'm trying to solve for a prime, and I just want to divide by I want to undo this division of 84 by multiplying both sides by 84. So I end up with A prime is 84 meters squared over 100 squared. So now I put 84 over 100 squared, so that's really over 10,000 squared. And I get 0.0084 or 84 10,000ths meters squared. So for further reflection, if you have taken chemistry, how is this similar to dimensional analysis? You tend to use tables in chemistry, or you might, later in college, they're actually going to make ratios instead of doing a proportion. And we'll practice some more of that when we get to our surface area. We'll actually be doing it, getting to the surface area and the volume unit. We'll practice switching with the dimensional analysis there.